How long is 1 second? That was 1 second. What can happen in this 1 second?
For us, maybe not much, but for the universe at its birth, a lot did happen. Every atomic particle forming the matter of all the planets, stars, and galaxies we see was created in this first second of the universe life. The four fundamental forces we observe today were formed in this first second. Time and space themselves were born at the start of this first second. And by the end of it, the universe was 1 second old, 1 billion kilometers diameter, and 10 billion degrees hot. Amazing, isn't it? But what is more amazing is how we could know so much about this first second of the universe creation. Welcome to Sci F3, where science is fact, fiction, and fun. Episode 8, Part 2, The First Second of Creation. Welcome everyone. In Part 1 of this episode, we could see how many scientists in the 1920s and 30s rejected the idea of the universe starting from an extremely small, extremely hot particle, despite the reasonable science leading to it, just because it appeared to suggest a creation process. I quote one of them saying, "The idea of the universe having a start and it was from a primeval size is pseudoscience, little different from trying to justify the existence of a creator." This rejection couldn't hold much against the overwhelming evidences of the universe expansion and the discovery of the cosmic microwave background in 1964. These evidences led straight forward to the conclusion that the universe started very small, very hot, and at a certain time in the past. But to know how the first seconds of the universe looked like, we needed other evidences. These evidences didn't come from observing the universe. Rather, they came from our labs here on Earth. And at the heart of it was the experimental particle physicists. Their main work was to smash hadrons, or atoms nuclei, at speeds nearing the speed of light, and study the resulting smashed atomic particles. They used for this hadrons colliders, and their edge notch of this was the Large Hadron Collider, LHC, owned by the European Organization of Nuclear Research, CERN, the largest particle physics lab in the world. In their repeated experiments, they accelerated the atom particles to such high speeds that if the accelerated particles traveled next to a beam of light, after 1 year of travel, the light beam is only 1 meter ahead of the accelerated particles. This means the Large Hadron Collider could accelerate these particles to an amazing 99.9999991% of the light speed. And for that, it needed energies up to 13 tera-electron-volt in its last upgrade of 2015. When we smash atomic particles at such high speed, they break into their elementary components, and a lot of heat is generated from the collision. Temperature in these experiments has reached 5.5 trillion degrees. Such temperature existed only at the early start of the universe, when its age was just 1 of 10 trillion parts of a second, so near to its start at time zero. Studying how the matter behaved in such high temperatures did lead us to a clear understanding about how the universe matter developed in its early age. Scientists could tell the story of the universe creation step by step from as early as 1 of 10 trillion parts of the first second, and all the way till now. To imagine how short is 1 of 10 trillion parts of a second is, imagine we stretched the first second to be as long as 316,000 years. 1 of 10 trillion parts of a second will be then hardly 1 second in these 316,000 years. To that early extent of the universe age, we have solid data about it. Amazing, isn't it? I mean, to build experiments in our labs making the same condition our universe was at such early fraction of its first second is really mind-blowing. But what about the time before that? Do we know something about it? Though our present experimental powers stop at this limit, at least till we build larger hadron colliders, but still, our quantum physics equations could theoretically explain what could have happened before that. And with theories like the inflation theory, we could derive how the large-scale structure of the universe was formed and found out that the early matter mysteriously outnumbered the early antimatter by 1 in a billion particle, allowing the universe to be built from the matter and not from antimatter. But how far our theories and equations can take us back in time? Actually, not much. Our physics equations fail at the Planck time of 5.39 multiply 10 to the power of minus 44 seconds. It is defined as the time it takes light to travel across a Planck length, which is as short as 1.62 multiply 10 to the power of minus 35 meters. It is the shortest possible time interval that can be measured by our present equations. The Planck's length and the Planck time defines the scale at which current physics theories fail. It is the scale where the effect of gravity, simply ignored in our quantum equations but appearing in Einstein's equations, starts to be too large to ignore. Please refer to episode 2, part 2, 4 Forces Control the Universe for more information. Does that mean that we have no idea about the universe before the Planck's time? Actually, yes. We have no data, no theory based on any physics or math that can say anything from time zero, the moment of creation, till the Planck's time, 5.38 multiplied to the 10 of a power minus 44 of a second. In fact, we need completely new breakthroughs in physics to describe this period. And of course, we don't know anything before the moment of creation too. In fact, all talks and hypotheses about multiverse, hypotheses about other universes colliding together to generate new universes, as well as parallel universes, are all lacking any scientific base. They are as good as the ancient myths about the universe creation. The only difference is the ancient man who invented these myths was holding a wisdom stick, while the nowadays myth tellers are holding PhDs. Both hypotheses lacked any scientific base. Actually, we can twist highly earlier statement to be multiverse and parallel universes are not more than pseudoscience, little different from trying to justify the denial of a creator. I hope you enjoyed our part today, and in next part we shall explore the steps our universe developed from Planck length until the vast size it reached today. Thanks for watching and see you next part.